Hello friends, welcome to the online education. This is the lecture number 2 and paper number 503, Physical and Analytical Chemistry. Now we have learned about our new chapter, Introduction of Complexometry, Titration. And previous lecture we have learned about the some terms, complexometry titration, chelate and ligand, and primary standard used as a EDTA solution. Now today we have learned about the EDTA titration curve and Welcher's rule. So what is the EDTA titration curve and Welcher's rule? First of all, we have learned about the some basic principle of Welcher's rule, EDTA titration. So first of all, most of the metal ion produce the 1-gem-1 complex. Which type of complex produced? So 1-gem-1 complex produced metal ion. Most of the metal ion produce the 1-gem-1 complex with EDTA. EDTA is a primary standard solution and it is the produce of 1-gem-1 complex ion. Which? So metal ion. Most of the metal ion produce the 1-gem-1 complex with EDTA solution. So the reaction between various types of metal ion in EDTA can be represented as given below. So we have learned about some basic reaction of metal ion and EDTA and produce a 1-gem-1 complex. So we have learned about some basic reaction. So first of all, metal ion with a bivalent metal ion or valency is 2. So it is called bivalent metal ion. Bivalent metal ion is reacted with a ligand H2Y minus 2 and to produce a My minus 2 ligand and to form a 2H plus ion. So bivalent metal ion is react with a ligand H2Y minus 2 and to produce a My minus 2 complex with 2H plus ion. Now trivalent metal ion is reacted with a ligand H2Y minus 2 and to produce a My minus complex and to produce a 2H plus ion. Tetravalent metal ion is reacted with a H2Y minus 2 ligand and to produce a My or 2H plus ion. So here the charge of our complexes is reduced. So first of all, bivalent metal ion, so charge of the complex is minus 2. Trivalent metal ion, the charge of the complex is minus, and tetravalent metal ion is reduced the charge and form the neutral molecule. So reduce the charge, and this is the basic reaction of a metal ion or EDTA solution and to form a 1-gem-1 complex. So in this way, 1 mole of H2Y minus 2 ligand, in this way 1 mole of H2Y minus 2 reacts with a 1 mole of a metal ion and to gives a 2 moles of a H plus ion. So this is in this way 1 mole of H2Y minus 2 is reacted with the metal ion and to form a 2 mole of H plus ion. So pH of the solution, it was increased or affected because H plus ion was produced. So pH of the solution is affected. Okay. Now we have learned about the Welcher's rule of the EDTA titration curve. So in this way we have learned about some basic reaction of EDTA with metal ion and to form a 1-1 complex. Now we have learned about the Welcher's rule. Complexes of bivalent metal ions with EDTA are more stable in an alkaline medium. Which medium? Alkaline medium. Complexes of bivalent metal ion. This type of metal ion. This is the bivalent metal ion. Is stable in an alkaline medium. Alkaline medium means basic medium. Bivalent metal ion are more stable in a alkaline medium. It means between pH is 8 to 10 because of alkaline medium. So pH is 8 to 10 because pH range of base is 7 to 14. So it is the more stable in alkaline medium and its pH is 8 to 10. So complexes of the bivalent metal ions with the EDTA are more stable in an alkaline medium. It means between the pH is 8 to 10. Now complexes of the trivalent metal ion, with the EDTA are more stable in an acidic medium, and it means pH is 1 to 2. Complexes of the trivalent metal ion. This type of metal ion. Complexes of the trivalent metal ion with a EDTA solution. It's more stable in an acidic medium. So its pH is 1 to 2 because of acidic pH range is 0 to 7. So it is the strong acid. It's a 1 to 2 pH. So complexes of the trivalent metal ion with EDTA are more stable in an acidic medium. It means between the pH is 1 to 2. And now complexes of the tetravalent metal ions with the EDTA are more stable in a highly acidic medium. Which type of acidic medium? Highly acidic medium. Tetravalent metal ion. This type of metal ion, tetravalent metal ion, are more stable in a highly acidic medium. So its pH is 0 to 2. It's a highly acidic. 0 range to 2 is a highly acidic medium, and tetravalent metal ion is stable in a highly acidic medium. So it is the rule number 3. Now rule number 4 is most of the metal ions except the alkali metal. Which type of metal is except? So alkali metal, and gives a soluble and stable complexes. Most of the metal ion except the alkali metal ion, and it gives a soluble and stable complexes with the EDTA. And this is the basic principle of EDTA titration or complexometry titration. So this is the 4 rules are under as the basic principle of EDTA titration and complexometry titration. So EDTA titration or complexometry titration follows the Welcher's rule. Now we have learned about the EDTA titration curve. So we have draw the graph of volume of EDTA versus pH range. So pH range 2 to 14, and we have draw the pH curve 3 type of constants K1, K2 and K3, and this value is 10 raised to 6, 10 raised to 8 and 10 raised to 10, and this is our endpoint or equivalent point. So this is the graph of volume of EDTA versus pH range, and we have learned about the endpoint or equivalent point with 3 constants K1, K2 and K3. This value is 10 raised to 6, 10 raised to 8 and 10 raised to 10. And we have learned about our basic reaction M plus N and Y minus 4. So M by N minus 4 is our basic reaction of a EDTA curve, and stability constant K is equal to M by N minus 4 is equal to M plus N and Y minus 4. So this is the stability constant K. We have calculated the value of a stability constant K is equal to m by n minus 4 upon m plus n and y minus 4. So this is the stability constant. So we have learned about the Dta titration curve and Welcher's rule. So it is the explanation of Dta titration curve and Welcher's rule. It is the basic principle of a complexometry titration and Dta titration.